Hi everyone, welcome to another video. This time I'm going to do the last 5 questions on a TMUA paper. The TMUA, what is it? Teaching Maths University Admissions or Test for Maths University Admissions or something like that, I don't know. But I think this is the last year they're doing it. Still though, I promise you, this paper has some great short questions which if you run out of short questions for the mat to practice, which you will, because the mat is not as heavily resourced as something like the STEP where there's just tons of papers. You couldn't do them all if you tried. The mat is different. You'll probably get through all the mat papers before the mat and you might think, oh, I want some more little practice questions. Well, firstly, it never hurts to use maths challenge material, but that won't necessarily test A-level ideas. The TMUA is really good for this, and definitely the last 5 questions on any TMUA paper, the last 10 questions really. TMUA is not easy, and the questions definitely at the back of the paper are roughly of equivalent difficulty to the mat short answer questions. Maybe slightly easier than the last 2 or 3 on the mat, but only just. It's of a good level. So extra practice, great opportunity. Now I was doing this with a couple of students, Rishi and Jeffy today, and they were doing really well. So let's have a look at this. Okay, so functions f and g are these two. What is the complete set of values of x? Yeah, so they want the whole set of values of x for which one of the functions is increasing and the other's decreasing. Well, an increasing function is where f dash of x is greater than 0. The gradient is positive. So I'm going to work out f dash of x first, and I just get 6x plus 12. And I'm going to work out g dash of x, and I get 3x squared plus 12x plus 9. Yeah. Now I want either one to be increasing and the other. Well, I want one to be increasing, so let's make it this one. So the gradient is going to be positive. This is going to be bigger than 0, in which case x is greater than minus 2. Oh, it's or equal to as well, just because it's not strictly increasing, it's just increasing. I've always had this in classes, increasing greater than or greater than or equal to. Well, if it says increasing, it's greater than or equal to. If it says strictly increasing, it's greater than. So there we go. Let's put that one to bed straight away. Okay, so this one's increasing. This one, we need it to be decreasing, though. So this one's going to be less than or equal to 0. And that's going to give us, just divide everything by 3 and factorise. Knowing how quadratics work with this, inequalities, that's going to be minus 3 to 1. Yeah. Now, minus 3 to minus 1, sorry. Now, if both of these have to be true, and they do, because we want one to be increasing and the other to be decreasing. Well, if I told you x was definitely bigger than minus 2, but also x was trapped between minus 3 and 1, surely the conclusion you're going to come to is x is trapped between minus 2 and minus 1. Yeah? Now, you might stop there, like naively, and think, oh, it's g. No, because there is another possibility. We said that the first function was increasing, the other was decreasing, but we could have easily had it the other way around. Or, yeah, this one is less than or equal to 0. 6x plus 12 is less than or equal to 0. And let's just go straight to x squared plus 4x plus 3 is greater than or equal to 0. Yeah? Well, if that's the case, then x is less than or equal to minus 2. And, yeah, always write your ands and ors down because they're important. You're going to have x is less than or equal to minus 3, or x is greater than or equal to minus 1, just because it's going to be the other way around to that. Okay, now how can this be true? Less than or equal to minus 2 and either less than or equal to minus 3 or greater than or equal to minus 1. Well, if we want this statement to be true and one of these two statements to be true at the same time, then we have to conclude that x is less than or equal to minus 3 because that meets this condition and this condition. And so the complete set of values is this one or this one, and hence the answer is in fact, what is that? Where is it? E, I think. There we go, that's that one. So that's really about logic, but questions are often about logic, so look out for that. Okay, what's 17? A little bit of integration and summation. Nice. Yeah, this one's not bad. I didn't think this one was too bad. They want g of n is bigger than 50. I'm going to start working with f of n. Now, we've got 1 over m up to n, from 0 to n minus x, but we're integrating with respect to x, assuming that n is constant. So let's do that. Let's just integrate it, because that will give you nx minus x squared over 2 between n and 0. This gives you 1 over m multiplied by n squared minus n squared over 2. Yeah, and then the zeros are going to give you nothing at all. Now, n squared minus a half n squared is just n squared over 2, but times that by 1 over n, and you've got n over 2. Yeah, and that's what f of n equals, n over 2. That's simplified it massively. What a load of, like, good way the examiner's trying to just confuse you by just putting lots and lots of intense algebra in there. Now, g of n is the sum from 1 to n of f of r. So g of n is equal to the sum from 1 to n f of r, yeah, which is of course the sum from 1 to n. Yeah. Now f of r is r over 2 because f of n is n over 2. F of r must be r over 2. Yeah. Now you can take the half out of the sigma safely, and then you're just summing r from 1 to n. And that, well, I feel sorry for them giving this to single mathematicians. Is that easy? I suppose it's an arithmetic series, you could argue. It's way easier though if you know the sum of r is just n times n plus 1 over 2, which comes up in further maths. Yeah. So we're going to times that by a half as well, because I forgot that half there. So that gives us n times n plus 1 over 4. So when is g of n? And remember, this is g of n. Yeah, so g of n equals n times n plus 1 over 4. So n times n plus 1 over 4 is bigger than 150. You can kind of do the next bit by inspection. Right, we want 600. We want a number times by one more than a number bigger than 600. I went for 24 at first, but 24 times 25 is 600. But we want it to be bigger than 600, so we need our n to be 25. Because that would be 25 times 26, which is like 650, isn't it? Yeah, I think, because 25 squared is 625, so one more 25 would be 650. Yeah, I think so. So I think the answer should be D. Yeah, and I'm just checking the answer key on my other screen, and we've got it right. Okay, this one, I thought this one was really easy, actually. The graph of y equals log base 10 of x, I'm just going to write log of x, is translated in the positive y direction by 2 units, so it became x, log x plus 2. That's how you move something up 2. The translation is equivalent to a stretch, I agree, because you could write 2 as log of 100, yeah, assuming this is both base 10, which I said at the start it would be, yeah, and that's because log base 10 of 100 is 2. So you can just write it like that, and then immediately come to log base 10 of 100x, and then realise, so moving it 2 up is equivalent to stretching it by a scale factor of 1 over 100, which is 0.01. And there we go, it's A. So that one's really quick. Okay, this one's not going to be so quick. I think this one I found the toughest on the paper. I had to do some thinking and almost got it wrong. There was, it's tricky. Okay, I firstly pretended this was an equal sign because I thought because then P and Q would be the roots. Do you know what I mean? When this is an inequality, then it's the roots. If I can just draw x squared plus bx plus c, yeah? Well, then those roots would be P and Q from the information they're telling me, yeah? Because that's where it would be less than 0. So in other words, they're telling me the roots of this quadratic are P and Q. That's what they're saying from that sentence. So straight away I thought, okay, well that's great. That means I know that x minus P, x minus Q must be equal to x squared plus bx plus c. Yeah. Look at any quadratic inequality, and when you solve it, you'll find that the roots are here and here. Yeah, for a quadratic inequality. So that means that P and Q must be the roots. Now, if we multiply this out, we'll have minus P plus Q x plus PQ equals x squared plus bx plus c. Okay, so that means that minus P plus Q must be B and PQ must be C. That's the way I figured it anyway. And then I started looking at their ugly one and thought, oh, But what I did was I just replaced B and C with P and Q, even though it wants it in terms of PQ and C, but I fiddled around with it at the end. I'll show you what I mean. So what have I got here? I've got x squared plus BC, so that's minus, let me make that minus P plus Q, in brackets, PQ, yeah? Okay, so I made it like that, x, yeah? And then plus C cubed, which is just P cubed, Q cubed, yeah? And I'm trying to solve where that is less than 0. Now, this isn't as bad as it looks. If you multiply that in there, and it just occurred to me that this might be the case. You get P squared Q plus PQ squared, don't you? X, yeah, plus P cubed Q cubed, yeah? I thought I need two numbers that add to give this and times to give that. Well, the answer for the two numbers is minus P squared Q and minus PQ squared, because they add to give this, clearly, but they also times to give that, because two minuses make a positive, and that times that gives you p cubed q cubed. In other words, you can factorise it now. And at that point, I thought, oh, I've done it. This is no problem at all. Because I was a bit worried at first. I was like, oh, it looks pretty weird. Okay, the one thing you need to be careful of is they don't tell you things for no reason at all, normally. They very rarely give you distractors. They normally is a reason for it being there. So why have they told us that c is less than 0? Well, if c is less than 0, your quadratic definitely hits the y-axis in a negative place, which just means that one of p and q must be negative and one must be positive. You know, if you think about it, if it's got a positive there, they're both negative, or they're both positive. But as soon as c is less than 0, as soon as it hits down there, then either p is negative or q is positive, or vice versa. And we know actually that p is less than q, so p must be negative and q must be positive. Yeah, that's what I've just learned from that bit of thinking. Really useful to think about that. So when I'm trying to work out the roots for this, I just thought, well, clearly, because it's less than 0, if you were to graph this, you've got to be slightly careful here. P squared is going to be positive and q is going to be positive. So the p squared q is actually on this side, whereas the pq squared is on this side because q is positive and p is negative, so it has to be on that side. So I want it so that x is between pq squared and p squared q. Now, do you remember we said c was pq? Well, that means that this is going to be qc is less than x, which is less than q, pc, is it? Yeah, pc. So which one is that one? QC and PC. So I make it D, yeah? And I think that's right. Let me just check my answer key. Yeah, that's right. Yeah, it's sneaky, that little it's less than 0 bit. Watch out for that. 20. Okay, quite like this one. I quite like this one. It's kind of nice. We're basically saying a triangle, triangle's three sides form an arithmetic progression here. A plus D, A plus 2D. That's what we're really saying. And, oh, I better label these. QR is A. So I guess that must be P. Check that makes sense. PR, RP is A plus D, yeah, and PQ is A plus 2D. Good. Okay, we're told this cryptic little thing, which I'll use later, but they want the full range in degrees of possible values of PRQ, yeah? Now, I hope you're getting to the point in your preparation for these papers of looking at something like that and thinking, cosine rule. It must be cosine rule. It's the only way we're going to try and, find that angle. So cos theta equals that squared plus that squared, a squared plus a plus d squared, minus this one squared, a plus 2d squared, all over 2 times by that one times by that one, 2a, a plus d. Yeah? Okay, and I thought, well, hopefully this comes to something, not nothing. So I multiplied it out and simplified it. Now we're going to get an a squared there and a squared there, but we're going to take away an a squared, so we're going to be left with a squared. We're going to get like a 2ad here, but we're going to get like a minus 4ad there, and so we've got minus 2ad. And then we're going to get a d squared minus a 4d squared, so that's minus 3d squared. And that's my quick way of doing it in your head, but be careful. Now, I just had a feeling, just through lots and lots of exposure to these kinds of questions, that the top is likely to factorise here, and I reckon one of the factors is either A or A plus D. It just looks like something needs to clear up. Now, I thought, well, let's try A plus D, and then I thought, well, that works with A minus 3D, doesn't it? Yeah, get A squared plus an AD, minus 3AD, that's minus 2AD, and then minus 3D squared. This is just basically having good intuition. Are they going to make something cancel? Probably, because then we get that, yeah? Now, you might not be out of the woods yet, yeah? My thinking when I got to this point went something like this. If I want to find out that angle, I know plenty about the cos curve, and so what I do know is, like, when cos is negative, theta's trapped between like 90 and 270, and so I kind of thought, well, is this negative? And I started looking back at this, because this seemed to be something they told us for a good reason. 3D is bigger than 2A, yeah? Let me just write that down. 3D is bigger than 2A. Let's check I wrote that down right, because if I write it down right, it's all going to be good. Okay, when I see an inequality like that, and I've got to somehow use it in my question, but this isn't just 3D, it's some other weird thing, I think, well, I'm going to turn that into that, because I can always manipulate inequalities, no problem at all. You can manipulate them. Did they say A and D are positive here? Yeah, A and D are positive. Okay, that, it's something else to bear in mind if you were to times by A or divide by D. You don't need to, because they're both positive, you don't need to worry about switching the sign. Now I want to make this, firstly actually I'm going to times everything by -1 to introduce minus 3D. Now that does switch it round because I timesed it by -1. Yeah. Then I'm going to add an A. Yeah. And I've got A minus 3D. And now what I'm going to do is I'm going to divide. Hang on, have I done this right? Yeah, I times by -1. And then I added an A to both sides. That's cool. A minus 3D. Lovely. And then I'm going to divide by 2A. Yeah. Now what do we get here? I'm slightly worried because I seem to remember. Should I have subtracted an A here or something? Maybe I did this. Have I made a mistake here? Have I written down something wrong? I'm getting my spidey senses tingling that something's gone wrong. 3D is bigger than 2A, so minus 3D is less than 2A, and so A minus 3D is less than 3A. Divide by 2A. Is it up here? Is this all right? A squared plus AD minus 3AD. That's good. That's minus 3D squared. That looks good to me. That looks good. So divide by 2A. And I get 3 over 2. I was expecting a half on this, or minus a half on this side, so I think I've done something wrong. Let me just see what I've done wrong. It's going to be something really obvious. Look at that. You're probably screaming at the screen, aren't you? Look at that. I didn't times that by -1 as well. I times this by -1. Thought, no, I won't bother timesing that by -1. So let's get rid of all this. This is all nonsense. Let's fix it from here. Okay, so I have minus 3D is less than minus 2A. I then add an A, so I get A minus 3D is less than minus A. That's better. And then I divide it by 2A. And you might think, why am I doing all this? Well, I just wanted to find out what this is in terms of this inequality, because then I know what cos theta is in terms of the inequality. Now, I'm dividing by 2A here, remember? And that gives me minus a half, yeah? So look at this. Cos theta is that, and that is less than minus a half. So what I can say is cos theta is less than minus a half. Brilliant. Woohoo. Okay, think of the cos curve now. Yeah? And minus a half is there. You should know that cos of 60 is a half. Yeah, this is how I figured this out. So cos of 120, because of all the symmetry, yeah, up to 90, that's going to be 120, that's going to be 60, that's going to be like 90. Yeah, cos of 120 is minus a half. So if we want to be less than less than minus a half, well, surely we're trapped between 120 and 240. Yeah, that's what I thought. And I went straight to the answers. I looked at them and thought, there's no 240. There's no 240. I must have done it wrong. I must have done it wrong. And then I remembered being taught that the angles in a triangle add up to 180 degrees. And I felt a bit silly. So the answer is E. But I did honestly, for at least 30 seconds, think, no, the answer's that I've done something wrong because I've got up to 240 here. But yeah, funny the things you forget when you're doing these kind of questions. But anyway, I hope that was useful to anybody watching. Last 5 questions of the TMUA 2017. I think these are really useful. I can keep doing them for 2017, 2018, 2019, whatever you prefer. I think there's some really good videos anyway on this from R2 Drew 2. Look up his videos. There's loads of people doing these, so feel free to, I'm certainly not the only person who can have a go at partially explaining them. But yeah, keep up the hard work, and bye bye.